Alright, so last time we started classifying chemical equations, and once we figured out what class they're in, we were able to predict products. For example, one class is combustion. What are the products of a combustion reaction? Carbon dioxide and water, exactly. So that's one of the classes, and we already reviewed the other classes already, all fitting into our overarching learning goal, which deals with a more solid understanding of chemical reactions in terms of writing them, balancing them, classifying them, and then predict products. So what we're going to talk about today includes single and double replacement. With single replacement, what you're going to see here, and we're going to keep this very simplistic. Now, I know when you go to parties, girls dance with girls. I guess guys dance with guys too, although I think you see more girls dancing with girls. To understand this concept, though, you have to have boys dancing with girls. Otherwise, it doesn't work. So, for example, in a single replacement reaction, what you are going to have is the following. A boy all by himself sees a couple on the dance floor dancing. Now this boy, shaded, is more powerful, if you will, than this boy. So he comes over, tap tap on the shoulder, and there is a changing of the couple. This boy now is out on his own, and this boy dances with this girl. So what you have here is an element and a compound on the reactant side of the equation, a new compound and element on the product side of the equation. And it only works if this boy is more powerful than this boy. What you're going to see in chemical reactions of this type, this is going to be metal displacement, in which you have a metal that's more powerful than another metal that's really a metallic cation that's linked through an ionic bond to a nonmetal. If this metal is stronger, if you will, than this, the lithium will displace the magnesium ion, bump it out. Magnesium will come out as a metal, if you will, no charge, no subscript on metals, and you will generate a new compound, lithium chloride, and you just finished your quizzes, so I'm sure you're masters at balancing at this point. The way you determine if this metal is more powerful and stronger than this metallic cation is through an activity series. And this activity series is on the back of your periodic table. That's what activity series is. So if you look up at the screen, you will see the activity series of metals. The higher on the list the metal is, the more powerful it is. So lithium has the ability to displace any metal below it. You will see hydrogen on this list. Hydrogen, of course, is not a metal, but it behaves similarly in this regard, so we include it on the activity series. So lithium has the ability to displace anything below it. Rubidium can displace anything below it, but it can't displace lithium. Cobalt can displace anything below it, but not anything above it. Can sodium displace nickel? Yes, because it's higher on the activity series.
What would happen if you, like, say you had potassium as the single element, and then the compound was, lithium chloride?
Okay, so
How would that work?
hang on. So if you had potassium plus, what'd you say, lithium chloride? Potassium is not more powerful than lithium, correct? So this does not happen, and we simply write NR for no reaction. That reaction doesn't occur. No. So, and you can actually test that through a series of single replacement reactions, which we'll do toward the end of the year when we talk about electrochemistry. That would not, you would mix the two together and nothing would happen. Whereas in the lab, you're going to mix magnesium and hydrochloric acid. This is perfect for the lab next week. Is magnesium of higher activity than hydrogen? Yes, it is. So magnesium will bump the hydrogen out. You'll get magnesium chloride. Just like with oxidation and synthesis, you must formula write the product. Okay? And now the hydrogen is displaced. Now hydrogen is one of those diatomic elements, part of the Brinkelhoff series. So this is the only time in metal displacement where you'll have a substance being displaced in a diatomic format, okay? You're going to see more of this in a few minutes when we get to halogen replacement, but this is the only time that you'll see it, okay?
And then you have to balance that.
And then you'd have to balance that. So what am I missing?
Just the two.
You got it. All right? And just the intro to here covers a lot of what we're going to see. It's all written out for you, but I really like this little dance couple thing because we're going to use more of it, and it really helps kids to understand. Okay? Questions? You're going? All right. So let's go back into our notes, and what you're going to see here is single replacement, also known as displacement, somewhat synonymous. This is an irreversible reaction, and let's go back to our equation so that you understand that concept, irreversible. So what you're seeing here is that lithium can displace magnesium ion, magnesium as an ion in an ionic compound, although you don't need to get that technical at this level, because lithium is higher on the activity series. Could magnesium displace lithium? No. So the reaction only goes in one direction, irreversible. That's what we mean by that term. And we already equated it with dancing. And when we say one partner, I guess initially he wasn't part of a partner. So maybe we want to make that clear. Equate with dancing and, what do you want to say, a single something? All right, hang on. Finish this thing. How should we phrase that?
A person bumps.
Okay, and one person bumps another out who was part of a couple? All right, maybe that's a better way to say it. All right, Ethan, fire away. Question.
So, if you have lithium and lithium chloride, what would happen?
Nothing.
Okay.
All right, so a metal always replaces a metal. I'm going to get those little dots out because those are going to drive you nuts. And that's what's shown here A metal of higher activity has the ability to displace the metal that's part of the compound here. That metal is now by itself. Can aluminum displace copper? Yes, because it's higher on the activity series. So aluminum displaces copper, copper goes out by itself, new compound between aluminum chloride that's correctly formula written.
What makes certain metals more powerful? Why?
It actually deals more with electrochemistry and reduction potentials, and that's a little bit involved, and I'll explain it separately, but that's a very involved process. All right, so we mentioned the activity series. It's listed here, but it's on the back of your periodic table. You do not need to memorize it. Let's take a look at the examples. We're going to walk through them very carefully. And again, this looks easy, but I have kids doing weird things. Make sure the metal displaces the metallic cation in that compound. So when you have a metal, you're going after the front. And I'll illustrate that clearly here. The first example, the directions are always the same. We've seen this numerous times already. In the first example, what we've got, it says lithium and barium chloride. And in terms of classifying, we would classify this one as single replacement, abbreviated SR. So the first thing I check is the activity series. Is lithium above barium on the activity series? Yes, it is. So lithium bumps out barium. Barium goes out on its own. And we generate lithium chloride that is properly formula written. Make sure you formula write those compounds. That will be a major mess. Be careful there. Formula write your compounds. And now you balance it off, which you're already super strong at. So we classified, we predicted the products, and we balanced. The metal displaced the front half, the metallic cation of that compound. It comes out by itself. No subscript. I'm so silly. No subscript, no superscript on a metal being bumped out. All right, so look at this one. We have strontium reacting with iron 3 iodide. What do we check? Chase.
Check to see if strontium is more powerful than iron, and it is.
How do you know?
Because it's higher on the activities.
You got it. Now what?
And then you have to formula write strontium iodide, and that's SRI2.
Perfect?
And then just Fe.
Yep.
Then you have to balance it, and it's 3, 2, 3, 2.
3, 2, 3. Yep. You got it. Perfect. Single replacement dealing with a metal. It doesn't matter if you put the compound first here or you put this first. Either way is fine. And it doesn't matter how you write this, so you can write these. Just make sure in the compounds that the metal, the metallic cation, is always first. All right, next problem. Ian, we have zinc and hydrofluoric acid. Ian, what's the first thing we check?
To see if the zinc is stronger than the hydrogen,
Perfect.
which
And
it is.
good. Now be careful with hydrogen. When this gets the boot, how does it come out? Diatomic. So it comes out as H2. And I tried to drop that major hint on your activity series by writing H2. Usually they just write H, but I threw H2 in there so that you'd remember. And how do we formulate this product, Robin? Correct. Where'd you get that 2 from? No. Be careful there. Where'd you get the 2 from? Zinc has a 2 plus charge in a compound, so that 2 dropped down. Be careful there.
What happens if the metal is a transition metal that can form multiple cations, and how do you know which one it is to formulate?
And that's an excellent question. When in doubt, go with 2 plus. Silver, of course, is always 1 plus. And
if it was, let's say, if it was copper plus hydrofluoric acid. Oh wait, I'm kidding, that wouldn't work. But if it was,
copper. I thought you said
if it was
cobalt.
cobalt plus hydrofluoric acid,
Okay, so let's do cobalt then.
it's copper's below.
Right, no, I thought you initially said, okay. So if we have cobalt and hydrofluoric acid, cobalt is above, and there could be more than one possible answer. When in doubt, you go with 2 plus, it's safe, because transition elements have 2 valence electrons, so it's safe to do that, and then you could balance it off. But if you had done cobalt 3 fluoride, that would be fine too. But yeah, and we'll come back to that concept in double replacement. Yep, excellent question. All right, and then we have platinum, and again, here platinum, if I flip screens for a minute in your notes, platinum's written out. Now platinum's an element on the periodic table, no subscript, no superscript. Don't do silly things there. And it's going to react with cobalt 2 sulfide. Can platinum displace cobalt? No. So we write NR, which stands for no reaction. That reaction doesn't occur. You wouldn't observe anything. In some of these other reactions, you're generating hydrogen gas, so bubbles will form. And you'll see that in the lab when you react magnesium with hydrochloric acid. You'll see rapid bubbling. And then we're going to put a lit flame in there, and we'll see what happens.
Like, so for once it bubbles and the hydrogen has escaped the container, wouldn't you, so at the end you would just have like zinc 2 fluoride?
In an aqueous format, so it would look like water. But we're going to try and capture the gas in the tubes. Okay. The next one says lithium and gold 3 sulfate. This one's a little bit different because we've got a polyatomic in there, but still very doable. What's the first thing we check, Carissa? And is it? Pardon? Yes, it is. I'm having trouble hearing. So what gets bumped out on its own? AU. Should I keep the 2 on it? No. And now we need to formula write that product. How do we do that? Hang on. We've got, I'm going to go right here. Lithium is in group 1. What's its charge? 1 plus. Sulfate, SO4 with what charge? 2 minus. So what do we make? You got it. All right. And again, we're just going to balance that off. And why don't you guys try the problem on the screen. It says silver nitrate and barium react. And I'll do it too, and we'll see if we've got it correct. And just be careful here, I wrote it backward, but it doesn't matter.
Can we formula write it? Can we put the barium first?
You can. The only thing you really have to be careful with is that when you formula write, make sure you have metallic cation, non-metallic anion, or polyatomic anion. It's got to be cation anion the way we learn. How'd we do? Not done yet? All right, you're working on it, right? So only look up if you have the answer. Whole bunch of you looked up. Do you all have the answer? All right. I think single replacement is the hardest, and that's because there's another category of it that you're going to see, and that one I think is harder than this one. This to me takes the most practice, the single replacement. Are we getting it? Yes, yes? Feeling good? And again, this one I just wrote backward. You'll recognize single replacement because you're going to have an element and a compound. And the element's either going to be a metal or it's going to be a halogen. And that's what I'm going to show you next. And again, as we march through this and we do it by class, it's relatively easy because we're doing all single replacement together. But then when you mix all 6 classes together, it gets a little tricky. So I've got an exercise at the end for you where they're all mixed up, and I also have another review sheet for you where they're mixed up as well, because I thought that would really help you. All right, now we're going to do another type of single replacement. The one we did initially is metal replacement. This one is going to be non-metal replacement, and specifically it's going to be halogen replacement. And what you're going to see here is that this time you're going to have a girl by herself, a couple on the dance floor. She comes over, bumps this girl out. So now we're bumping the back half, and you're going to form a new compound between this metallic cation and this halide ion. It was a halogen, but in the compound it's an ion, a halide ion from group 17 predominantly. So we're just going to deal with halogen replacement. For example, fluorine, a diatomic element, reacts with lithium chloride. Fluorine has the ability to displace that chloride ion. I'll explain that activity series in a minute. And when it does so, chlorine gets bumped. Now your halogens are diatomic, so it gets bumped in a diatomic format, and now you generate lithium fluoride. You put the metallic cation first. So this one's a little different. You have the halogen that displaces the halide ion from group 17. This displacement works based on the activity series shown directly on your periodic table. So for example, if you consider the periodic table shown on the screen, your halogens are in group 17. Fluorine at the top of the periodic table has the greatest activity of the halogens, then chlorine, then bromine, then iodine. So you simply go straight down the group. Iodine does not have the ability to displace any of these halogens. So that's the weakest of the group, if you will. Fluorine is the strongest of the group. So the activity series for the halogens is right on the periodic table from top to bottom. So this is halogen replacement. This is the one that the kids find the hardest because they put all kinds of weird things together. Make sure you put a metallic cation and the halide ion. We're not, yeah, that's in group 17. It's not diatomic, and we're not going to play with it. So we'll keep it simple, but good question.
So it's not gonna ask that on the test.
Nah. I don't give you anything you haven't seen before. All right, here's your basic format. You're going to start with a halogen that's more powerful than the halide ion here. This halogen can displace the halide ion out. When the halide ion gets displaced, it's the halogen, and you have a new compound. Different properties than what you started with. The activity series is as we showed. For example, fluorine has the ability to displace the iodide ion. It gets displaced as iodine. Fluorine is higher up on the periodic table. It bumps out the back. New compound. Why is this no reaction?
Iodine can bump out fluorine.
You got it. Iodine is the lowest in that grouping, and it doesn't have the ability to displace the fluoride ion. This is NR for no reaction. Let's walk through several here. The last grouping is the easiest. This to me is the trickiest. Directions the same as we've seen 6 times between going through everything last time and this time. Classify, predict, balance. So they're all going to be classified as single replacement. You can recognize them as single replacement because you're going to have a halogen and a compound. So these will all be classified as single replacement. And here we go. Single replacement SR, that's going to be all the way throughout. In the first one, we have fluorine reacting with barium chloride. What do we test?
You see if fluorine's higher than chlorine, and it is.
Absolutely. So that's going to get displaced. It does get displaced as Cl2, a diatomic element. And how do we formula write this product?
BAF2.
You got it. And that came from the 2+ charge on barium. That's already balanced, easy peasy. We've got chlorine reacting with iron 3 iodide. Now this gets back a little bit to your question, Chase. It wasn't your question per se, but it sort of fits the bill.
This one kind of tells you back in the 3 on the high.
You got it. So you know that the charge of iron in this compound is 3+, because iodide's 1-, so this 3 came from the 3+ here. So you're going to maintain that charge here. What do we test, Garrett? Is it? Yeah, so it goes. So now, this one's a little bit trickier. You don't bump out I3. What do you bump out? I2, diatomic. And now, when you formula write, you know the charge on iron is 3+, so you have iron 3 chloride. And then you very simply balance it off. So be careful with one like that. In the next one, I have iodine plus hydrofluoric acid. And what do I test, Trey?
To see if you said iodine.
Yes.
Iodine is higher than the fluorine.
Is it?
Oh, wait.
It's like how high it is in that row.
On the column.
Oh, yes. Oh, wait. Well, fluorine is higher.
Right. So does this react?
Wait, does the,
Can iodine displace that fluoride ion out?
no.
No. So this would just be no reaction. Okay? Here's where you have to know your diatomic. I know some of you were like, oh, what are those diatomics for the quiz? But I didn't put that on the quiz per se in terms of writing. But here you're going to need it. The next one says chlorine gas. How do I write that? Cl2. Reacts with cobalt 3 bromide.
Br3.
Perfect. So the charge on the cobalt ion is
Positive
3+. Good. Now what am I checking, Rebecca? And is Cl more powerful than Br? Yes, it is. Good job. Now let's just be careful here. What gets bumped? Go ahead, Andrew.
The bromine.
Like that?
No, as a subscript to
Perfect. And what do you make for the compound?
CO3.
You got it. This had a 3+ here, 3+ here, and then you just balance it off. Okay? Try the last one. It's on the screen, toward the top. Actually, at the tippy top. Only look up if you've got it. Go ahead, Robin, what do you got?
Oh no, it's stretching.
Did you get it?
Yeah.
All right. This to me is the trickiest. So if you're following here, that's a really good sign. But I'm going to warn you, and I've told you before, practice, practice, practice. Chemistry is not a spectator subject. If you don't practice, you won't own it. So we've talked about single replacement. We've done it with metals, where we bump the front half out. We've done it with non-metals, specifically halogens, where you bump the back end out. And now we're going to talk very briefly about double replacement. The kids find double replacement to be the easiest of the bunch. You just switch partners. So for example, with double replacement, what you have here is you have a boy and a girl. This sometimes happens at a wedding, like parents are dancing and then they want to make nice to the in-laws, so they switch. And what you find here is that this boy is going to dance with this girl, and this boy is going to dance with this girl. Now the boys are going to represent the metallic cations, so they'll always go first when you're formula writing. So this boy dances with this girl, and this boy dances with this girl. A lot of kids are like, oh, it's foil. You do the outers and the inners. Whatever works. All right? So for example, and this one is in your notes, this one's actually a little bit harder. Doesn't matter, you guys are super smart, so it doesn't matter. You can do the hard one. If you had lead 2 nitrate reacting with potassium iodide, the metallic cation from this compound is going to bond with the anion from this compound, and you're going to get lead 2 iodide. Lead had a 2+ charge here, which you can get from here. 1-. Formula write that product. And now you put the insides together, always starting with the metallic cation first. Potassium 1+, nitrate 1- is potassium nitrate. And I do want to point out one other little piece. It's not really going to come together in this chapter, and you won't be assessed per se on it. What you find in these double replacement reactions, which are also known as metathesis reactions, this is in your notes, is literally you're getting a changing of partners. And metathesis is the Greek word for changing partners. So you're changing partners here. But what you can see in the equation written here that's balanced is that in the double replacement reaction, you've got 2 aqueous solutions, that means dissolved in water. One of the substances that you generate is a solid, a precipitate. We did a lab on precipitates earlier in the year. Remember you got those chunks and they were different colors? And you're going to see that in the lab as well next week. So one substance is a precipitate. It's insoluble. It won't dissolve in water. The other substance is aqueous. You actually can write net ionic equations based on that, but we'll hold off on that concept till we get to solutions and you know which substances don't dissolve in water. For right now, what I want to focus on is predicting the products of double replacement reactions and writing balanced chemical equations. You will recognize a double replacement reaction because you will have two compounds now, and they're both going to be ionic compounds. You're going to generate two new ionic compounds, one of which is insoluble in water. So let's march through here. What we've got, question? Oh, stretching. Okay, so what we've got here in regard to the classifying, these are all going to be double replacement, which we will abbreviate DR. We'll recognize them because you have two compounds. You have sodium fluoride and barium sulfide. And again, outsides and insides. Now, question?
No, I was gonna.
You want to do it?
Yeah.
Okay, go ahead.
You're gonna end up with sodium sulfide. And
All right, so hang on. I just want to do this one slowly only because it's our first one. We're going to put the two outside pieces together. And yes, that is sodium sulfide. Why'd you put the sodium before the sulfide?
Because you have to, because it's a metallic cation.
Right, sodium is the metallic cation. Metal, non-metal. And the other product is?
Barium fluoride, BAF.
And again, the barium goes in the front because it's a metallic cation. And you,
Because barium has a 2+ charge and sulfur has a 2+ charge.
sulfide has a 2-. That's where that 2 came from. Correct. And smack the 2 there. And kids find this to be the easiest. One thing I want to make clear, it never occurred to me that kids would do this, but about 10 years ago, somebody did. She wrote no reaction. You do not use the activity series for double replacement reactions. No activity series for double replacement reactions. That came up one year and I felt very badly. It never occurred to me somebody would do that. Those are for single only. All right. Barium iodide reacting with sodium phosphite. Who wants to do it? Then I'll just pick. Allison. Got this, girl. What's it going to hook with? Good. And then you'll formula write that. Good. And don't forget those parentheses when you formula write with polyatomics. That's what some of you did on the quiz. And what's your other product? NAI is correct. Couple things to keep in mind here. You're putting the insides together. You're not hanging on to those subscripts unless they're part of a polyatomic. These are monatomic ions, and so you don't need those subscripts. You formula write Na is 1+, I is 1-. And when you first started to do it, you were doing it backwards. You were putting the I first, and then you realized, and why did you put the sodium first? You can think of it that way, and that'll work. The sodium goes first because it's the metallic cation, so you always put the metallic cation first. And if you're not sure, whatever went first on the left Has to go first on the right. Now I usually do outside then inside, but you can have this substance before this substance. A plus B is equal to B plus A, so it doesn't matter. All right? And then just balance that guy off and you're set to go. The balancing should, you know, be a piece of cake at this point. All right. We've got aluminum sulfate reacting with strontium chloride. Sarah, what do we do? Good. How do we formula write that? Al. I just don't think I heard you properly. Aluminum has what charge? Three plus, and Cl would have what charge? 1 minus. So how do you formula write that? Exactly. And what's the other product? You got it. Perfect. 2 plus, 2 minus, and they cancel. Excellent. That's a sloppy 4. I hope that came out okay. So, 3, 3, 2. And as you can see, this just takes a little bit of practice. We have more examples up there, which I think you're ready to roll on. Leave yourself a little space. Well, you have everything in your notes. So 4 and 5 I'm going to let you do separately in a minute. I'd like to do 6 with you just because it involves formula writing, but it's really not an issue. And on 6, you have lithium iodate, correctly formula written. Did I miscount?
No, on number 3,
Uh-huh.
how come when it was strontium chloride? Oh, because SO4 is 2 minus.
You are correct. So lithium iodate reacts with barium arsenate. So the only thing different here is you have to formula write the reactants. And then you predict the products the same way. Do you want me to do more with you, or do you want to give it a shot? Give it a shot. Okay. I want to let you work with each other. I want these 4 done. Oops, can't see anything. Huh? I want these 4 done. That'll be a good indication that you're doing double replacement properly. This concept of net ionic equations, I'm going to come back and explain that to you later when you understand solubility. The last piece of the notes really is an exercise in which every single thing is mixed together. And I'll give you the remaining time in class to complete the 4 I mentioned and try and do these 7. You can complete all of your classwork at this time, and if you really want to be ready for the test, I would recommend that you work on that over the long weekend. I won't see you again until Wednesday. We can address any questions or concerns at that time. we will do what I'm hoping is a very cool lab in which you're going to actually be carrying out many different classes of reactions. So that'll give you the opportunity to do a lot of this experimentally, which I think will help you greatly. And that's really the chapter in a nutshell. So hopefully at this point you are comfortable with writing equations, balancing chemical equations, classifying chemical equations, predicting products. And at this point, it's just going to take practice. The half day probably will serve as a good review day. Your lab would run Wednesday. So Wednesday we'll do the lab, we'll finish the whole thing. Thursday will be a really good day to put it all together, and then your test will be the following Tuesday. Questions? All right, I'm going to cut this.